Hello and welcome to Mentora IAS. I am Safir and I am here to take your journey forward with current affairs. So this particular class, we will first be discussing what we missed in the last class. Very sorry about that, and thank you so much for kindly pointing it out that I missed the topic. So today we'll be starting with that particular topic, that was Super Typhoon Ragasa. But at the same time, I would also like to tell you that today all the topics are from geography. Okay, so don't get scared. Geography is a very simple and a very logical subject. Once you understand the basics, that's all. Okay, that's a rock solid subject, one of the easiest and shortest subject to cover. Okay, so let us begin with that particular thing. But before we begin, I would like to draw your attention towards the social media handles that we have, and I would really want you to subscribe to our social media handles. Okay, especially YouTube, Instagram, and Telegram. Telegram is basically the place where you will be getting the handouts, and subsequently YouTube is where you have all your videos. And trust me when I say this, that all videos are basically available free of cost. So these videos are there to help you understand things better. Okay, and then subsequently with respect to Telegram, YouTube, and Telegram, Facebook, and Instagram, you will be having a lot of other UPSC centric activities like quizzes, updates regarding other important events of the day, sometimes something more important things for prelims that may just be read out instead of you can say coming out with a video on that. So we'll be having those things posted regularly. So please help us build our channel, and at the same time also help yourself augment our preparation. Okay, so all your handouts, all the detailed handouts that I have been talking about in all my videos, they are available at the Mentora IAS official channel. That is basically the Telegram channel we have. So all the annotated PPTs that we give and all the detailed handouts apart from this will be available there, so that you have a ready reference material to understand what is to be read additionally if you have understood the video. Okay, so there are always things that we may not be understanding. So those things will be covered by you after you have the handout. So handout gives you the baseline. Now whatever you want to add on, you may. Okay, so let us begin the session today, and today we'll be talking about three important topics. The first one coming from the previous session, that will be Super Typhoon Ragasa. The second topic that we'll be talking about is basically polymetallic sulfides. Okay, and the third topic that we'll be talking about will be Indian monsoon, because the monsoon season technically has ended, and the Indian Meteorological Department has recently given performance of the overall monsoon this particular year. So let us begin with the very first one, Super Typhoon Ragasa. Okay, so this particular image that you're seeing is an image that is taken from the International Space Station. Okay, so this image has been taken from the International Space Station. Okay, and this is basically a space observatory that we have outside the Earth. Okay, it is located in the low Earth orbit. Okay, and subsequently it is the one where we conduct a lot of experiments with respect to the absence of gravity, with respect to how the body and physiological responses change with respect to the life on Earth versus the life on you can say life on this particular you can say space pod. Why? Because this is basically the test ground for the impacts of solar radiation on the body. Okay, because at this particular height there is no ozone layer, nothing. You are exposed to the direct radiations of the sun. Okay, so it is very important for us to understand that in order to build any interplanetary mission, okay, or for that matter in order to go for any extraterrestrial mission, what kind of physically demanding qualifications would be required, or what exactly is going to be the impact of the solar radiation on our body. And subsequently we develop technologies for space suits, for the space capsules, the space shuttles and all. Okay, so this also takes pictures of the Earth. It observes what exactly are the phenomenon on the surface of the Earth, and this is what it captured. Now this is not a zoomed image. This is something which has been taken. You can see this is basically the if you see this particular thing is actually the space flap. Okay, this is basically the one which is the wing of the ISS, or the International Space Station, where it has its solar panel mounted. So this is a camera which takes up this particular photo, and see the expanse of this particular typhoon. Okay, so when you talk about typhoon, you can call it hurricane, you can call it cyclones. Okay, they are all same things, but all of these are basically tropical in nature. So they are all tropical cyclones. So the fundamental concept is that these are all tropical cyclones. Now they have different names in different places. Okay, so they are called typhoon somewhere, they are called hurricanes somewhere, they are called cyclones somewhere. Okay, so it is more like the same person having multiple names, like pet names and real names and then pen names if you actually write something as an author. Okay, so the same person, but they have different names in different places. Okay, so this is basically how you actually define what exactly is a cyclone's name. Okay, then when you talk about this particular word ragasa, now ragasa basically tells you that this particular cyclone has been distinctly given a name. Why? Cyclones are given a name in order for better reporting and in order for better identification, because if cyclones are not given a name, cyclones may happen at the same time at multiple places in the world. Okay, it is not sure, or it is not the case that it will happen only at one particular place and it will not occur at some other place. So that is why what we need to understand is that in this particular scenario, we need to name the cyclones and also at the same time we need to track individually all of them. Okay, so cyclones are named according to a protocol that is given by the World Meteorological Organization. Okay, now the third word here is super. This tells you the intensity of this cyclone. So with the expanse of the clouds, what this whitish things is actually the clouds which have been formed due to this particular cyclone or the typhoon. Okay, and these clouds cover a major chunk of the earth. So it basically means that this was a very big, massive cyclone that struck the you can say Eastern Asia, and that is why it is called Super Typhoon Ragasa. Okay. So let us now understand what exactly was there in the news. So before we go there, these are your questions that you will need to find out the answers to during this discussion, and at the same time, if you know the answers, please do comment. Okay. So the first question here, consider the following statements about tropical cyclones. So this is basically a statement based question where you have two statements given and you have to identify which of them are correct. Okay, and then subsequently you choose the correct answer. So you can now pause the video and read the question carefully and try answering it. Now, this is basically the second one. Okay, the second question that we have, and this question is basically an assertion reasoning type of question where the first statement basically is a fact and the second statement is supposedly the explanation why the first thing is happening or the first statement is happening. Okay, so first of all you have to evaluate factual correctness of both of them, and after evaluating this we have to then evaluate if the second statement explains why the first statement happens. Okay, so pause the video and subsequently read this question carefully and try answering it, and if you don't, please do find the answer in this particular session itself. Okay, keep your eyes peeled. So pause now. Okay, now let's go. So in the news, what exactly has been the thing? So we have a cyclone that has been named Ragasa, and this particular cyclone struck East Asia. Okay, so this particular cyclone struck the East Asia. So this particular cyclone was the one which was recorded in the Pacific Ocean, and specifically in the Pacific Ocean, if we talk about it, the western side of the Pacific Ocean. Okay, so this was basically the biggest cyclone that has been recorded in 2025. Okay, and it was so enormous that it actually made multiple landfalls at various places. So what exactly is the landfall? Landfall is basically the first interaction of a cyclone when it is moving from a water body to the land. Okay, so just like you step, okay, when you step you actually have to climb from one floor to the other, you use the stairs. So the first step that you take in order to go into the stairs, now that is something which is called as the landfall here. Okay, so because of its intensity, because of its enormity, it made several landfalls throughout the region. Okay, so that is why this was something which was called Ragasa. So this was given the name Ragasa by the Japanese Meteorological Department. Okay, the Japanese Meteorological Department officially named this particular cyclone as Ragasa, and that is how it is internationally recognized. Now the Philippines actually named this particular cyclone Super Typhoon Nando, because Philippines was the first country to experience the landfall of this particular cyclone. Okay, so this particular cyclone was the one which crossed over from China, Taiwan, Hong Kong and southern China, finally ending up in Vietnam and also having its effects to Laos. Okay, So you might be finding it a little difficult that how exactly to remember these countries or where exactly are these countries located. So we also have done a video on the South China Sea dispute where we have very carefully explained the entire map of the location. Okay, so you can also watch that particular video. Now, when we talk about this particular cyclone, it originated in the Pacific Ocean, on the Western Pacific Ocean in East China Sea, and subsequently it made its first landfall in Calayan Island of the Philippines. Okay, so the first landfall was on September 22 at its peak intensity. Now after it crossed the entire island, then subsequently it moved over and it entered into the South China Sea. Okay, and when it moved into the South China Sea, it then stormed the coast of China and Taiwan. Okay, so it basically stormed Hong Kong, and then subsequently it you can say moved to South China in the Guangdong province on September 24. So in 2 days, from September 22 to 24, this column of air crossed over from Philippines, crossing over the entire South China Sea towards the mainland China. Okay, and subsequently then it basically dissipated completely in Vietnam. Okay, on September 2025. So two things that can be observed from here. Okay, what exactly can we observe? Landfall. So we have landfall. We have various dates. We have September 22. Okay, we have September 24. And subsequently then what we have is September 25. So in September 22 to 24, it was basically this time when this cyclone was traveling across two different countries, Philippines, crossing the South China Sea, moving into southern China. Okay, and then finally on September 25, it dissipated as well. So what do we understand from this? It is a very fast moving system. That's the first thing that we should be understanding. Second, it is very short lived. If you count it in the number of days, it dissipated in 4 days. Okay, so this is something that we need to understand. So this is what we are actually looking at when we actually look at the geography. So in geography, we say that tropical cyclones are short lived. Now the reason is why they are short lived. Okay, and you have just seen how exactly this particular cyclone, which was supposed to be super typhoon, the biggest tropical cyclone of this year, this is the one which lasted only 4 days. Okay, so this was basically the path. So when you look into this particular map, you have various things here. Okay, so this is the Pacific Ocean's western side. Now you may have its names. Okay, when you talk about these water bodies, they may be called, this is East China Sea, this is Philippines Sea, that is fine, it's okay, but the point is all of them are a part of Pacific Ocean. Okay, so this is the western side of Pacific Ocean, which is the side of Asia and Australia. Okay, and this is Taiwan. Taiwan was also known in the past as Formosa. Okay, so that is why this particular water body, okay, this water body which separates China from Taiwan, this is actually called the Strait of Formosa. Okay, so when we talk about the United Nations, so in the United Nations, the permanent member to the United Nations Security Council was basically a China, which was led by the government which is right now in Taiwan. Okay, now in 1971, the mainland China, this China actually took over the seat of this government. So today we have this People's Republic of China replacing the China, okay, of past. So this is again something we have covered in United Nations systems. Okay, so watch that video as well. Okay, so there you will be getting a very good history of how exactly the things were. Now this particular water body in between is the South China Sea. Okay, this is the South China Sea. Now what has happened that the first landfall was made in northern Philippines. Okay, the Philippines is basically a large group of island. A group of island is called archipelago. Now from here the we can see that this is basically continuously moving in this direction. Okay, this is another thing that we need to understand, that from the South China Sea this tropical cyclone is continuously moving towards the western side. Okay, because with respect to the Philippines, all these things, China, Vietnam, Laos, all these things are actually towards its west. So it crossed this entire thing and dissipated in Vietnam. Okay, it dissipated in Vietnam, having caused some amount of rainfall in Laos as well. Okay, so this is something which happened within a span of 4 days. Okay, so this is basically the track of the cyclone. Now, when we talk about tropical cyclones, what are it? So first of all, understanding tropical. So tropical basically is the geographical region. Okay, what geographical region are we talking about? This is basically the region between 23.5 degrees north to 23.5 degrees south. So this is basically the region that is called tropical region. Now in this particular region, there is a particular latitude which is 0 degrees. Okay, and this is basically the equator. This is also a part of the tropical region. Now why am I singling out equator? I'll just tell you. Okay, when we talk about tropical cyclones, so tropical cyclones, we need to understand the occurrence. Where do they occur? Okay, so tropical cyclones occur. Okay, they occur in the latitudes of approximately 10 degrees north to 23.5 degrees north, 23.5 degrees north, and subsequently same in a similar fashion 10 degrees south to 23.5 degrees south. Okay, so this is basically what we have as the tropical cyclones zone of occurrence. So what we have left out here is the region between 0 degrees to 10 degrees north or south. Okay, this particular region we do not see the occurrence of any cyclone. Okay, and this is because in this particular region we find there is negligible Coriolis force. We'll be discussing that as well. Okay, this is the next thing that we need to understand. So these are certain basics that we have to understand before we go into the concept of tropical cyclones. Now, what exactly is a cyclone? So cyclone is a rapidly rotating or whirling column of winds. So with respect to column, okay, so column is something that is actually starting from the ground and it is rising up towards the sky. That is column. Okay. Now rotating column basically means that it basically rotates like the spinning top. That top actually spins on its axis or the nail. Okay. So in a similar fashion, this is something which is continuously going to rotate. Okay. Then the next thing, this is basically a rotating column of air. So this basically means that here the air is basically going to rise in a similar fashion towards the top. Okay. So cyclone basically comes from the Greek word cyclos. Okay, there is a Greek word cyclos. And it basically means the coils of a snake. So just imagine a long snake like a python or an anaconda. It basically coils itself. Okay, when it is trying to camouflage or subsequently it is trying to hide, what happens is that you are going to find them, you can say, arranged as coils. Okay, in a similar fashion, what happened was that one of the British personnel who basically was manning one of the meteorological stations in Calcutta, he basically saw this thing with his binoculars, and subsequently to him it appeared to be like the coils of the snake. Okay, and subsequently that is something which basically prompted him to give this name cyclone. Okay. So in this particular regard, what we see is that tropical cyclones have been named such. So their area of occurrence is between 10 degrees north to 23.5 degrees north and 10 degrees south to 23.5 degrees south. Okay. Now, why exactly are they occurring? So now we have to study that as well. Why exactly are they occurring? Okay. So that is the next part of the story that we have to understand. So now let us begin with how exactly the tropical cyclones are formed. So there are certain conditions that we basically have to talk about in terms of the formation of tropical cyclone. Okay, so let us talk about these conditions. Okay, so the first conditions required for a tropical cyclone. So the first thing that we'll be requiring is basically a pre-existing low pressure zone. Very important. Okay. The next thing that we'll be requiring is basically a large undisturbed body of water. Temperature at least 27 degrees. Okay. Third thing that we'll be requiring, which is very, very important, is existence of Coriolis force. Okay. That is the third thing we'll require. Fourth, absence of vertical wind shear. Fifth, divergence at upper atmosphere. Okay, these are basically the 5 conditions that we have to see, and once these conditions are found, then it is basically the conditions which are favorable for the formation of a tropical cyclone. So what exactly do we understand from this? We understand one thing, that the temperature should be at least 27 degrees Celsius. This means what? This means that it can happen only in regions experiencing summer, or warm weathers. Okay. Now that is basically a characteristic of the tropical region, that in the tropical region throughout the year we have the greatest amount of insolation throughout the year annually. Okay, and absolute maximum is at the equator, and within the tropical zone you do not find a lot of you can say variation in the temperature as well. So that is why this is basically the place which is confined within the tropical region. Now why exactly are these conditions needed? Okay, so the first thing that we have to understand is that we have to have a low pressure zone. Low pressure zone basically means that in this area the air is rising towards the sky. Okay, so the air which is prevailing over the ground should be rising towards the sky, because when this air is evacuated from the ground, so that is something which will create a depression, or that will create a deficit of air in that particular region, and then subsequently we are going to say that this is where we are having low pressure zone. Why do we need the low pressure zone? So low pressure zone is required for air to flow in. Okay, so naturally the air basically flows from a high pressure to a low pressure. It's a natural thing. Okay, all the things in the world, they always flow from a higher value to a lower value. The easiest thing to understand this, loans. Okay, if you have money on yourself and your friend asks you money, if you have it, only then you will be able to give it. Now imagine that you do not have money, or you have just the enough amount of money for you to survive the month. Will you be able to extend that loan? No. Okay, so you can extend that loan or extend that help only if you have sufficient money. Okay, and that sufficient money will be over and above what you require. So that excess amount of money is basically the surplus you have. Okay, and that amount of money which you are loaning to your friend or lending to your friend, now that is the deficit which that person has. So where did the money flow from? Naturally it actually flows from the person who has money to the person who is in need of money. In a similar fashion, everything in the world, okay, you talk about a ball, or a ball which is placed over the slope. Okay, if a ball is placed over a slope, what happens? You place it at the top of the slope, it is automatically going to come down. Okay, when you actually keep a warm you can say a vessel or a warm cup of tea just like that open in the air, what we are going to find? We are going to find that this particular thing is going to cool down on its own. Why? Because the surrounding temperatures of this cup is basically colder than what is the temperature of the tea. So heat naturally flows out from the tea towards the surroundings. So that is what we need to understand, that low pressure zone is going to attract air from all the sides. Okay, and when this air is going to be attracted, what exactly is the scenario that we are going to see? So we will be having a low pressure zone. So when a low pressure zone is created, so what exactly is the scenario? Let us say this is the ground. Okay, this is the ground, or for that matter in this case water. Okay, and the temperature, let us say, is 30 degrees Celsius. So what happens when the air is actually blowing over it? When the air is actually blowing over it very close to itself, so what is happening? The heat is going to transfer. This heat is going to transfer from the ground or the water to the air. Okay, because the air is relatively colder than the ground. Okay, why? Because air is a poor conductor of heat. Okay, so what happens? The heat actually flows into the air, and because of this what happens? The air becomes lighter. Okay, so when heat goes into air, okay, so it becomes lighter, and when it becomes lighter, what happens? This air gradually starts rising up. So now this particular air is going to start rising up. Okay, this is basically what we are going to see, and this vertical movement of air is what we know as convection. In geography, this is convection. Okay, the vertical movement of air. Why? Because it has absorbed heat from the ground, or for that matter the water, and now it has become light, it rises up. This is convection. So because of this what happens? This air which was present here, okay, this air is now going to be in deficit because some amount of air has now risen up. So whatever was the volume of air, some part is going to be less, and that some part less is actually the low pressure. And because of this what happens is that it attracts winds from all the sides. Okay, this is basically what is going to happen. But where do you think these winds are coming from? These are coming from the regions which are at relatively high pressure. Okay, so all of them basically are coming from the regions which are at relatively high pressure, because if there are any more low pressure zones, then what is going to happen? It cannot give you that amount of air because it is already deficient in air. Okay, just imagine that when you have to help your friend, when you have just sufficient money to survive this month, you will not be able to help that person regardless of how dearly you want to help them. Similarly, this is the case with the air as well. Okay, so the high pressure zones are basically the regions where there is surplus amount of air, and this surplus amount of air now flows towards the low pressure zone. Now there is also a speciality of the high pressure zone. High pressure zones are created, okay, they are created by sinking of air to the ground. Sinking of air to the ground. Okay, so why does the air sink? Air will sink only because of one reason, that is gravity, and because of gravity it actually falls down under its own weight. Okay, so this sinking can only happen, okay, this can only happen when the air is cold. So when the air is cold, it is heavy, and when it is heavy, it will sink down. Okay, when the air is warm, it is light. When it is light, it will rise up. That is exactly why low pressure zones are actually associated with warm conditions and high pressure zones are associated with cold conditions. So what can we expect out of the wind that is coming towards the low pressure zone? They will be relatively colder. See, I am using this word relatively again and again because in terms of geography and especially in terms of climatology and oceanography, you have these terms pressure, temperature always in relation to each other. Okay, the temperature of this place may be 30 degrees centigrade, the temperature at that place may be 10 degrees centigrade. So relatively that place is colder. So whatever wind is going to come will be relatively colder to the wind that is prevailing here. Now because of this, what is going to happen? These high pressure zones are going to supply this particular wind towards the low pressure zone. And when this happens, so at that particular situation, what do we find? That these winds, okay, they start warming up. Why? Because they are cold and they start absorbing the heat from the ground or from the regions that they are flowing into. Okay, Now what happens is that when the air warms up, it has the ability to absorb more amount of moisture. Okay, so it is just the similar way that when it is the month of summer, you basically want to wear loose clothes and you can stretch your arms wide. Okay, but when it is winter, you basically clench to your whole self, you actually are shivering. Why? Because the temperature outside is colder than your body, so heat flows out of your body, so you actually keep yourself clenched very tight. But during the summer time, you basically are very relaxed. You do not want your you can say limbs to actually touch each other as of now, because it will sweat. Why? Because the temperature of the air around you is greater than you, so that is why you are feeling hot. So that is the whole point here. Okay, so what happens is that when the air is traveling towards the low pressure zone, it will continuously keep on absorbing the heat from the ground over which it is you can say traveling. Now because of this, the capacity of air to evaporate moisture also increases. Okay, and subsequently what happens when this low pressure zone is found over water, so all these parcels of air, all the air that is coming in, will also have the ability to absorb that moisture or absorb the water from the surface of the ocean or the water body. And subsequently what happens, it would want to penetrate into this low pressure zone. Okay, so the objective is that whatever is the excess amount of air present, that wants to come down here, so that whatever is the low pressure zone is fulfilled, and as the when they all attain the same temperatures and the same pressures, the airflow will stop. Okay, when they all have the same pressures, the airflow will stop, and till the time it is not the case, the air will continue to flow. So now what happens in the low pressure zone? In the low pressure zone, we see that if this low pressure zone is situated in the regions of 10 degree north to 23.5 degrees north, or 10 degrees south to 23.5 degrees south, in that scenario we find that the air here, okay, it is going to feel a deflection. Okay, and that deflection is due to Coriolis force. So Coriolis force is basically a force that comes into play because of the rotation of the earth. So any given moment, we are right now on the surface of the earth, we are all rotating at the same velocity at which the earth is spinning on its axis. That is why we have the sensation that 24 hours is the duration of the day and night. Okay, it means that all of us experience the you can say the day and night just because we are on the surface of the earth and we are spinning at the same velocity as that of the earth. But what is the difference? The difference is that we do not feel this spinning. Okay, had it been the case that you basically were in a giant wheel or a merry-go-round, you would experience that when you are spinning very fast, you are going to find yourself pushed here and there. But because the earth is very, very large, so you are actually observing a very minuscule portion of the earth. Okay, doesn't matter what exactly is your vision, but you are observing a very, very small portion. And subsequently in that particular scenario, what happens? That we see that the air basically is the one which is actually you can say also feeling the same kind of thing. But the point is that air is covering a large distance. Okay, so the air is covering a large distance over the surface of the earth in order to reach this low pressure zone. So it feels a deflection due to the rotation of earth. Okay, and that deflection is basically given by Coriolis force. So Coriolis force has the job to deflect the air in a certain direction depending upon the hemisphere. So in the northern hemisphere, when we talk about the Coriolis force, so Coriolis force, okay, the cause is rotation of earth. Okay, and what exactly is the effect? The effect is deflection. Okay, deflection of air or water. Okay, now it depends upon three things. Okay, the magnitude. So when I talk about depends, it is basically the magnitude. The magnitude depends upon wind velocity. Okay, angle of latitude. Okay, predominantly we can be talking about these two things, okay, with which the Coriolis force changes. If the wind velocity is very high, Coriolis force will be very high. Okay, if the angle of velocity, angle of latitude, the latitude in which this wind is right now, okay, based upon that we'll be having Coriolis force. So this means that Coriolis force will be maximum at poles. Why? Because at poles the angle of latitude is 90 degree north or south. Okay, it will be minimum at equator. Okay, and that is effectively 0 because it is 0 degree, so it will be 0 there. Okay, so Coriolis force has the effect of deflection of the wind. Okay, and how exactly is this deflection taking place? When we talk about the deflection, it will be towards right in northern hemisphere, I am writing NH for it, and towards left in southern hemisphere. Okay, I hope this is something which is clear, that the deflection is towards the right in north hemisphere and towards the left in southern hemisphere. So subsequently in this particular regard, what happens is that the Coriolis force is deflecting the wind in a certain direction. That is why I said that in the northern hemisphere and southern hemisphere there will be a deflection. So what does that entail? It means that these winds which are supposed to travel from the high pressure zone to the low pressure zone in a straight line, they will not be able to travel in a straight line. Instead, what is going to happen, that they are going to travel in a curved path. Okay, so in the north, so I will just be drawing that quickly as well. So let us say that the green arrow represents northern hemisphere wind and we have the orange arrow. Okay, this represents southern hemisphere. Okay, so I am going to draw both of them in the same diagram, but you can always check for it. Okay, so when we talk about the wind which is flowing in the northern hemisphere, so in the northern hemisphere you are going to be deflected towards the right. So in that particular manner, what happens, that this is something which will be seen, that in the northern hemisphere, how do you determine the deflection? The deflection will be determined by facing yourself towards the direction in which the wind is flowing. So keep your face in the same direction in which the wind is flowing. So that basically means the arrowhead, and based upon that arrowhead determine what is your right and left. Okay, so once you have determined the right and left, so what is going to happen, that when you talk about the hemisphere now, north or south, that is going to determine the direction of deflection. So in the north hemisphere, what is going to happen, you are going to be deflected towards the right. Okay, so just imagine that this is basically the direction of the wind flow. So what I am going to do, I am going to stand in the direction of the wind flow. So when I stand in the direction of the wind flow, I determine what is my right and left. So this becomes the left, this becomes the right. Okay, so instead of moving straight into this low pressure zone, what is going to happen, I am going to see that the wind is going to be deflected towards the right. Similarly, this will also deflect towards the right, this will deflect towards the right, this will also deflect towards the right. Okay, now if I come here, now my direction changes. Okay, now my right side is that and this is my left side. So now the deflection will be like this. Now when you see from top to bottom, okay, again you have a deflection towards the right and left. So you basically are facing in the downward direction from north to south. So here the deflection will be like this. Okay, so effectively what happens is that if I now erase very carefully these you can say small things, if I erase this very carefully, okay, what do I find now? Now I find that the direction of the wind is something like this. So instead of flowing into, okay, what is happening, it is getting deflected. Okay, and in the manner of deflection, what exactly is happening, I am seeing that the overall direction here is in this particular direction. All the winds are deflecting and from the top it looks like they are rotating like this, counterclockwise, opposite from the direction in which clock rotates. And This is exactly the way in which cyclones rotate in the northern hemisphere. Okay, you can again you can do the same thing. You can again very carefully, if you can remove this, this will help you. Okay, so I'll remove all these arrows again. Now when I remove these arrows, what happens? This is basically what I see. So instead of coming straight, what is happening? It is now moving in this direction. So the low pressure zone does not get fulfilled. So what is going to happen? Because the low pressure zone is not receiving the winds, so whatever is the wind here, whatever is the air here, it will continuously keep on warming. So when it is continuously keep on warming, it will continuously keep on rising. And this thing is going to only aggravate the situation. And in this particular manner, what do we find? This is something which is going to be creating a situation where wind is flowing in an anti-clockwise sense. And while it is flowing, what is also happening? A part of it is also rising up because it is warm. It is warm, it is not getting cold, and subsequently you basically have the rotation of the wind and you are rising up. So when this is seen in a 3 dimension, it seems like a coil of rising air column, that is basically called cyclone. Okay. Now what is going to happen in the southern hemisphere? Just the reverse. In the southern hemisphere, now what is going to happen? Instead of the right hand side, the deflection will be towards the left hand side. So this entire direction which is right now twisted here will turn the other way. Okay. So in the southern hemisphere, the low pressure zone is going to be, you can say, seen to be where the winds are going to rotate in a clockwise sense. Okay. So this is the concept of cyclone, if you understand. Okay. Now basically what happens when the winds are the one which are actually rising from the ground towards the top. So in this particular scenario, what happens is that when the air goes away from the surface of the land, it experiences cooling or falling temperatures. Okay. So as it moves away from the land, it moves towards the sky. So it basically cools down. When the air is cooling down, so what happens is that the moisture that it has absorbed from the water, okay, or from the water body, that needs to be lost. Okay. So in this particular scenario, what happens? The water is basically the one which cools down. Okay. So when the water cools down, so this water gets separated out from the air, and this is something which is called as condensation. Okay. So now the next step would be that we have condensation. Okay. So now we are talking about the wind which is actually moving from the ground to the top. Okay. So let us say this is the way in which the wind is actually moving. Okay. So this is the ground. This is ground. Let us say this is 3 kilometers. Okay. And this is basically 10 kilometers from the surface of the earth. Okay. This is basically the altitude or height. So what happens at various altitudes? We basically see that the wind or the air is cooling down. So when the air cools down, so at that particular time, what happens? The water vapor, okay, which has been, you can say, mixed in air, that is something that basically is something which is actually in the air, and it now separates out. So when it is separating out, then at that particular time, what happens? That this water separates out as a agglomeration or assembly of such water molecules. Okay. And these water molecules eventually are going to come together and make clouds. Okay. So what happens when the air is cooling down? So is the water cooling down. So there is a particular process when water turns into vapor or steam or gas. Steam, vapor or gas. Okay. So this process is called evaporation. Okay. And the reverse, when it is basically the steam, when steam turns into water, okay, steam or gas or vapor, it turns back into water. This is called condensation. So what happens is that when you have to turn from water to steam, so in this particular case, energy is required. Okay, and this energy is basically called latent heat of vaporization. And when you have to cool down, okay, so when the steam is going to turn back into water, so at that particular time what is going to happen? It is going to lose energy. So when you are going to lose this energy, this is basically lost as latent heat of condensation. Both of them are exactly the same. Okay, latent heat of vaporization and latent heat of condensation, they both are same. Why are they called latent heat? Because this particular heat cannot be measured using a thermometer. The thermometer is basically a device in which we basically measure the temperature. So when you are not able to measure the temperature, so that is something which is called to be latent, that although there is a loss of heat, only then you have turned from steam to water, but this is something which cannot be quantified in a thermometer. So that is called latent heat of condensation. Now where is this heat lost? This heat is lost to the air itself. It is the air which is going to lose, which is going to receive this heat, and subsequently what is going to happen? It is again going to rise the temperature of the air. So air is going to become warmer because of the loss of this heat at the top. Okay, so when the air becomes warmer, subsequently again it is something which can go down, evaporate the water and come back again. Okay, so there is always a constant rise and then subsequently a constant sinking of the air that happens. Okay, this air which is sinking, although it was cold at the top, but it received some amount of heat because of the latent heat of condensation, and then subsequently when it came to the bottom, it became warm again. Again it will rise in this manner, and this is something which will continue as long as there is water beneath the surface. Okay, as long as the ground is basically the one which is covered with water. Okay, so till that particular moment, this is something which is going to happen, because the water is something which is required for the formation of clouds. Once the water is finished, now basically what is going to happen? There is nothing to absorb. There is nothing to absorb. So subsequently now what is going to happen? The air will not have any moisture. So even if it rises up, it is not going to have any kind of cloud formation. And when no cloud formation, no rainfall. Okay, so I hope this is clear. Now this is exactly the tropical cyclones cross section. So from the top we have just seen cyclone Ragasa's picture, that it looks something like this. Okay, that there is a eye and eye wall. So eye is basically the central part. Okay, and this central part is something which is also clearly visible from the top. So what does this mean? If you are able to see it from the sky, and if you are literally sitting at the eye, you will still be seeing the sky because there is no cloud. So eye is basically a zone of calm. Okay, eye is the zone of calm. Zone of calm, warm air. Okay, so here you are not going to find anything, and this is basically the low pressure zone. This is the low pressure zone which the air wants to completely fulfill, but the point is, because of the Coriolis force, it is not able to penetrate into the low pressure zone and it is swirling around. Okay, so this eye is basically that low pressure zone, and then subsequently all the you can say spirals that you are actually seeing, these are basically called rain bands. Okay, so these are rain bands. Okay, they are basically clouds which have been formed because of the enormous amount of evaporation that is happening from the level of the ground. Okay, so when you cut this cyclone in half, this is what you see, that at the center you basically have an eye, and in the eye you basically have a rapidly rotating and rising column of air. But the point is that this rising column of air is something which is spreading out at the top. Okay, so at the very top you find that the clouds basically are spreading out. So this is upper air divergence. So at the top it is spreading out. And when it is spreading out, so because of the rapid rotation of the tropical cyclone, this entire series of clouds, they spread out over a long you can say area. Okay, in a large area they basically spread out, and when they spread out they basically cause rainfall in the nearby regions. Okay, so what is happening, that just beside the eye is something called eye wall. Now eye wall is the place which has the most violent kind of winds. Okay, because from this point onwards there is no inward movement of the air. From here the air is only going to rotate, and that is why the rotation is very rapid, and that actually you can say pushes the air up because of the warmth, and subsequently you can see this, that the air at the bottom is warm, and as it moves towards the top it gets cold, and once it gets cold, so it is losing out all its moisture, it is converting into clouds, and those clouds spread over a very large area. And at the same time some part of this air also sinks down. Okay, why? Because it is now cold, and because it is cold it wants to sink down. When it sinks down, it actually receives the heat that is released by the air which is rising up, and again it gets warm, it goes back, it evaporates, comes back up again. So this is basically the cyclone. Okay, I hope this is something which is clear. Now this is basically the eye. This thing, if you are seeing, this is basically the eye of the hurricane Katrina. Katrina was one of the most devastating tropical cyclones that hit the US. Okay, and this is basically the eye of that particular cyclone, and the clouds have risen up towards the top. So a research plane accidentally happened to get inside this particular zone of clouds, and this is what you see as the vicinity inside the eye. So the air is rising up, you can see how exactly the clouds are enormously large clouds. Okay, and from the top it is basically open to the sky, that is completely clear. Okay, so I hope this is something which is clear. This is basically the eye. Okay, now this is how a cyclone actually moves. So tropical cyclones have a tendency that they move from the east side to the west side. Okay, this is the east side. What we are seeing here is actually North Atlantic Ocean. Okay, so on the Atlantic Ocean, on the eastern side we have Europe and Africa, on the western side we have North America and South America. So again we see that the tropical cyclones have a tendency to move from east towards the west. We saw the same thing with respect to Ragasa as well. Okay, so in this particular regard, what do we see? That we have this particular cyclone moving in this direction. Why is this happening? Because these cyclones in the Atlantic Ocean, they basically are formed due to the movement of the trade winds. Okay, so the trade winds, when they are actually moving, when they come from the continent side to the water side and from the colder regions to the warmer regions, so they warm up, they take up the moisture, and subsequently they start becoming cyclone. Okay, and once they become cyclone, they get pushed towards the land, and when they are moving towards the land, they are also acted upon by the Coriolis force. So when they are acted upon by the Coriolis force, what is going to happen? They start turning towards the right. Okay, and once they turn towards the right, what also happens is that they cross the tropical latitudes altogether. They cross 40° north, and then subsequently they become extra tropical, because now they have moved beyond the tropical region. They become extra tropical. They again cause rainfall at various places as an extra tropical cyclone. Okay, now why does this happen in the South China Sea and also with respect to the Indian Ocean, that is basically Bay of Bengal? That the cyclones actually come towards the coast of Odisha, you will say Andhra Pradesh, then subsequently Tamil Nadu, West Bengal. Why do they receive cyclones? Because these cyclones are traveling from east towards the west, and that happens because of the flow of an easterly jet stream. So these easterly jet streams during this particular time of the year, they blow from east direction to the west direction. So over India, they flow from Bay of Bengal towards India. Okay. So that is basically how they push these cyclonic storms towards India. Okay. Similarly, whatever are the cyclones that are actually getting formed in the Arabian Sea, they usually move towards the Arabian Peninsula, okay, towards Oman and those regions. But sometimes they do recurve like this. So when they are going to recurve like this, they basically become very strong, and they become very devastating. Why? Because the longer they basically spend their time on the ocean, and the longer they are able to absorb this amount of moisture, the greater would be the cloud spread. Okay, and the greater would be their intensity of winds. and subsequently in that particular manner what is going to happen, we are going to find a lot of destruction. Okay, so what happens is that the cyclones actually perform a lot of rainfall, extensive, huge amount of rainfall. But apart from the rainfall, what also happens is that when that whirling system of winds, they move towards the land, so they also pull some amount of water from the ocean. Okay, they pull some amount of water from the ocean, and when they are coming towards the land, they basically get this water actually inundating the land. Now this is something which is called as the storm surge. Okay, so whenever basically there is a low pressure zone or a cyclone passing over the water body, it brings some amount of water with itself because of the rising air. So the rising air pushes the water towards the land, and that is something which inundates the region. Okay, now if a storm surge is coinciding with a high tide or a low tide, it is going to aggravate the situation. Okay, it is going to completely aggravate the situation. Okay, so this is basically a storm surge, and this is something which brings in a lot of inundation in the coastal regions. Okay, so this is a major you can say aspect of damage. So see, all the you can say the cyclones throughout the world in the tropical region. So I will just draw the tropical region out for you. So this is basically the Tropic of Capricorn, and this is the Tropic of Cancer. So in this particular region, we see that the cyclones are actually moving from the east side towards the west side. Okay, in all the regions. So in India and in this region, there is a tropical easterly jet, TEJ, tropical easterly jet, that dominates this time, June to November. Okay, in this region, when you talk about the Atlantic Ocean, okay, so here basically it is the trade winds that actually are moving in that direction. Similar is the case with here as well. Okay, trade winds. Now the point being, when you talk about this entire region, okay, so what do we find? That all these regions have got different names for the tropical cyclone. In the Indian Ocean region, it is called tropical cyclone. Okay, in the Western Pacific, okay, in the Western Pacific region, it is called typhoon. Okay, in this particular region, the Atlantic Ocean region, it is called hurricane. Okay, and this region of Australia, it is called Willy Willy. So they are just the various names of tropical cyclone in various regions. Okay, one marked exception of this particular occurrence is the Southeast Pacific Ocean. Okay, in the Southeast Pacific Ocean, there is negligible chance of cyclones, and there are multiple reasons for this. First of all, there is no passage of the intercontinental convergence zone. So intercontinental convergence zone is basically intertropical convergence zone is basically the zone where the winds, the northeast trade wind and the southeast trade wind, they converge together. Okay, so that is something which does not come here. The second reason, here we basically have a cold current. Okay, so this cold current keeps this entire region very cold. The water body is very cold, and because of that, what happens is that in this particular region, we do not find any kind of cyclones coming up. Okay, so this is a marked exception. All the other regions have this particular thing. Okay, this was also a pre-YQI, by the way. Now, the intensity of cyclone in the United States is actually measured by a scale that is called the Saffir-Simpson scale. So they basically categorize the cyclones or the hurricanes, as they call it, based upon the wind speed that prevail over the ground. This is called the sustained wind speed, and in that particular manner they have 5-tier classification. Okay, with 1 being a normal and 5 being the most extreme. Okay, so the super typhoon Ragasa was actually classified in the category 5 hurricane. This is something which is going to completely demolish any kind of thing that comes in front of it. Okay, so that is what you basically see here, that in the tier 1 there is minor amount of damage and there is rainfall. In tier 2 there is some amount of damage to the property and there is snapping of the electrical lines. Then in tier 3 or category 3 kind of hurricane, you are going to find that it is going to cause damage significantly to your property. Fourth, there will be even significant damage. There will be uprooting of trees, uprooting of the electrical poles, and in fifth one, everything can go away. Okay, so this was basically where super typhoon Ragasa was, and it was a very intense cyclone as well. Okay, so what you're seeing here are basically two different cyclones. Okay, Now this particular cyclone is actually Chaba. Okay, this is Chaba and this is basically hitting Japan. Okay, this is another cyclone. This is another typhoon. This is Pacific Ocean. This is a typhoon. This is a typhoon. That is hitting Taiwan. Okay, this is Taiwan. Here we have Taiwan, and this is, you can see that it looks smaller than this. Now this is basically graduating into super typhoon. That is a smaller one. So this is why I told you that the cyclones are named in order for their proper identification, tracking and reporting. Okay. So in the same time, there are two different cyclones that are actually interacting and they are affecting two different regions of the world. Okay. So that's the thing. We need to be very, very careful about it. Okay. Now let's talk about the questions that we had. The first question, consider the following statements about tropical cyclones. The source of energy of a tropical cyclone is the transfer of latent heat of vaporization. The second one is tropical cyclones cannot survive for long without an open source of water. Okay. So the source of energy of a tropical cyclone is the transfer of latent heat of vaporization. I just told you that this is something which makes the air continuously warm, and that is basically the one which actually gives the air the ability to rise, because it is able to absorb this moisture and then subsequently it rises up. Okay. The second one, tropical cyclones cannot survive for long without an open source of water. Absolutely true. So the correct answer here would be both 1 and 2. Okay. Now the second question. Consider the following statements about tropical cyclones. Tropical cyclones do not occur near the equator. The presence of high deflection due to Coriolis force prevents the winds from entering the equatorial low pressure belt. So the first statement is correct, that tropical cyclones do not occur near the equator. We have just seen that. And the second one, the presence of high deflection due to Coriolis force prevents the wind from entering the equatorial low pressure belt. This is wrong. Near the equator, the Coriolis force is 0. Okay, this deflection is going to be 0. It is not high deflection. So this is wrong. So just identify the option where statement 1 is correct and statement 2 is wrong. So that is, I guess, yes, this is the one. Sorry, statement C, option C. Okay. So that is basically the answer to this question. I hope you got the right answer and you also understood the concept of how exactly this is to be done. Okay. So this is basically all about Super Typhoon Ragasa.